All right, today we're jumping into something really cool, Merg-E. It's a unique, highly specialized, domain-specific language. We're going to touch on its core philosophy, for sure. But what we're really going to focus on, what we're going to tear apart, is one of its most fascinating and powerful features, the operator extension system.
So here's what's on the docket. First, we'll get our heads around what Merg-E actually is, and then dig into its pretty strong-willed philosophy. Then we get to the fun part, how you can actually extend the language with your own operators, how the whole system keeps things from falling apart with precedence, and we'll even look at a very uniquely named escape hatch. Finally, we'll tie it all together and ask, why does any of this matter? Okay, first things first, what in the world is Merg-E? You know, this quote really hits the nail on the head. Merg isn't trying to win any awards for being a pure academic language. Not at all. It's all about being practical. It takes some of the best ideas from really powerful concepts, like object capabilities, the actor model, functional programming, and mashes them together to get a specific job done. And this right here is the main thing you need to get. Merg is not your do-everything language like Python or C++. It's a specialized tool, a scalpel, designed for very specific surgery, building things like L2 nodes and bots for Web 3.0. And everything is built around this core idea called the principle of least authority. Basically, security is the name of the game.
Okay, so this is where we get to the heart of what makes Merg-E, well, Merg-E. It doesn't try to be everything to everyone. In fact, it's the opposite. The language is incredibly opinionated, and it makes some really deliberate, strong choices, all for the sake of keeping things simple and safe.
And this philosophy, it leads to some decisions that are, frankly, pretty wild. You need to store complex data. Forget about structs or dictionaries. You're going to use something called a directional acyclic graph. You want to use classes and objects? Nope, not here. You'll use closures. I mean, it strips the language down so much that there's only one single keyword left. Scope. That's it.
And this comparison really lays it all out, doesn't it? Merg-E is the laser-focused scalpel. It gives up the do-anything flexibility of a general-purpose language, the Swiss Army knife. In exchange for that limitation, what you get is extreme power and safety within its very specific world. Okay, so that brings up a pretty obvious question, right? If the language is so minimal, if it only has one keyword and throws out common features like classes, how do you actually add new functionality? How do you get anything done? And that's the big puzzle Merg-E solves, and it does it in a really slick way. It's not through traditional operator overloading, which, if you've ever used it, you know can get really hairy and confusing. Instead, it uses a much cleaner system called operator extension. It's actually a pretty elegant two-step dance. First, you write the code that defines what your new operator actually does. You know, the brains of the operation. Then you just tell the language, hey, whenever you see this cool Unicode symbol, I want you to run that code. So, for instance, a line of code like this one just creates a simple alias. It tells the compiler, from this point on, that inverted omega symbol, it's just a stand-in, a shortcut for my logic called _my_operator. That's it. It's that straightforward. Okay, so that's cool and all, but you can probably see the problem this creates, right? If you start mixing your brand new operator with built-in ones like plus or multiply, how does the computer know what to do first? It could get chaotic real fast. This is where Merg-E's precedence system comes in, and it's all about safety. The way Merg-E handles this is super clever. It uses these things called precedence bands. You see, you can decide the order of your own custom operators, but they are always stuck in their own sandbox, the user-defined band. This means you can never accidentally create an operator that has a higher priority than core math, like multiplication, and you can never make one with a lower priority than assignment. The core language rules are protected. All right, let's actually see how this plays out. We've got this line of code that mixes everything together, plus, multiply, and our new custom operator. So, what happens first?
Well, thanks to those bands we just talked about, the parser first scans for anything in that top-tier high precedence band. And it finds one, the multiplication. So before it does anything else, it handles 14 times quaz and groups that up.
All right, what's next on the list? Addition. Both plus signs have the same precedence, so the parser just works its way through from left to right. It groups Baz plus 7, and then it groups the result of our multiplication with 5. Simple and predictable.
And it's only after all that core built-in stuff is sorted out that the parser finally gets around to our custom operator.
This system guarantees that the order of operations is always predictable and always safe. You can't break the fundamental rules of math.
Now, you might be thinking Merg-E sounds super rigid, and it is, but it's also not naive. The designers understood that every once in a while, a developer runs into a weird edge case, a situation where they know better than the compiler. They need an escape hatch. And that escape hatch has a name, the hazardous modifier. You can think of it as the developer literally putting a tag on a piece of code that says, "Warning, I am intentionally doing something the language considers unsafe, but I've thought about it and I'm taking full responsibility." It's a big flashing sign for anyone reading the code. And make no mistake, the compiler does not take this lightly. If it sees that hazardous keyword, its default reaction is to just stop. It'll throw an error and refuse to compile the code. It basically throws its hands up and says, "Nope, not going to do it unless you explicitly force its hand." And how do you force its hand? With this, the absolutely perfectly named Trust Me Bro compiler flag. It's a funny name, but it's also a brilliant piece of design. It forces the developer to explicitly acknowledge, yes, I know this is risky, but compile it anyway. Trust me. It recognizes that sometimes the human in the loop knows best.
Okay, so we've been deep in the weeds with operators and compiler flags. Let's pull back up to 30,000 feet. We've seen how Merg-E works, but why does a language designed like this even matter? What's the big picture? What this all boils down to is a really different way of thinking about how to build a language. Everything is designed from the ground up with that principle of least authority in mind. It proves you can have a language that's incredibly minimal and safe, but still powerful and extensible, as long as you build guardrails. And maybe most importantly, it's pragmatic. It acknowledges that no system is perfect, and sometimes you just have to trust the developer. Which kind of leaves us with one big final question to think about. In a world where we desperately need more secure, more reliable software, is this kind of opinionated, safety-first philosophy we see in Merg-E a glimpse into the future? Is this what the future of secure coding looks like?